My name is Amit Bhardwaj. Today we will discuss the topic time, speed and distance. Okay. So basically we will study this chapter by 3 or 4 concepts, right? Let's say concept number 1. The concept number 1 is when we will say that time will be same. What does it mean? It means, for example, if this is point A, this is point B, right? From this point A, Ram start to move towards B, and from this point B, Sham start to move towards A. Okay, and they both start at same time. Both start at same time. Okay, it means if they both start at the same time, both will meet at somewhere between A and B. Let's say this point is C. They both will meet at point C. So we can say that if time is same, because we know that Ram will take same time as Sham will take from B to C. What does it mean? It means we all know that speed is equals to distance by time. Speed is equals to distance by time, right? So can we say that time taken by Ram from A to C is distance by speed? Let's say this distance is d1 and this distance is d2, right? And Ram is moving with speed s1 and Sham is moving with speed s2. Okay, so can we say that time taken by Ram from A to C is distance, that is d1, and that is speed, that is s1. And the time taken by Sham, can we say that time taken by Sham is again from B to C? So can we say that B to C is, that is d2 and divided by speed is s2. So can we conclude that from these two equations d1 by s1 is equals to d2 by s2. d2 by s2. So what does it mean? It means whenever time will be same, the distance ratio, that is d1 by d2, is always similar to speed ratio, and that is s1 by s2. Okay. By using this concept, we will discuss one more example here. Let's discuss one more example on this topic. The topic will be, let's take example on this, right? The example is, let's say the concept is d1 by d2 is equals to s1 by s2. Okay, let's say one example. For example, a policeman saw a thief at a distance of 200 meter. Okay, and he starts to catch a thief, right? And policeman will move with 12 km per hour, and thief will move 10 km per hour. Okay, the point is, find after how much distance thief will be arrested. So what does it mean? It means, let's say if this is policeman and this is thief, right? Okay, and this is distance is 200 meter. When the policeman saw this thief, the distance between these two is 200 meters. So can we say that policemen start to move in this direction with speed 12 km per hour, and thief start to move with this direction 10 km per hour, right? So can we say that, let's say the policeman will catch this thief at this point. Let's say this point is Q. So can we say that now? It means the policeman take same time as thief took from point C to Q. So can we conclude that the time taken by policeman is equal to the time taken by thief? So can we say that this 200, let's say this is x. So 200 plus x, this is d1 for the police, right? Divided by the d2. d2 is thief distance, right? That is x, the distance covered by thief. That should be equal to s1, the speed of policeman, that is 12, and divided by the speed of thief, and that is 10, right? Can we say that This is equals to 2, 6, 12, 2, 5, 10. We will solve it. 5 to 10, 0, 0. This is 5x and this is equal to 6x. Can we say that x equal to 1000 meter? Because this is 200 meter. Okay, can we say that ki after traveling 1000 meter, thief will be caught by police. Okay, this is the concept number 1. Okay, now proceed on concept number 2. This is concept number 1. Now proceed in question number 2. And the question number 2 is, let's say, where distance will be same. What does it mean? Distance is same. It means, let's say, distance is same in this case. Distance will be same in this case. What does it mean? This is concept number 2. Let's say this is your office, right? And this is your home, right? Right. Let's say this distance is d. The distance between office and home is d. Okay. Ram start towards home from office with speed s1 and take t1 time, right? On another day, Ram move with speed s2 and take t2 time. So in both cases, Ram covered same distance. Okay. So what we can conclude from here, we can say that d is equal to, in first situation, s1 t1. In the second situation is also s2 t2, because d is same here. Can we say that s1 t1 is equal to s2 t2? Okay. In this case, can we say that the speed ratio, that is s1 by s2, must be equal to the t2 by t1? Okay. So we can conclude that the speed ratio is the reciprocal of the time ratio. Okay. So in the second case, we will take the case where speed ratio is equals to the reciprocal of their time ratio. Okay. It means this time for this one, this time for this one. Okay. Now take a question on this topic, and the question is, let's say this is person A office, right? And this is person A home. Okay. Right. This person move with 4 by 5/5 of his usual speed. And this is question. And reach 5 minutes late. So find actual time taken by this person to reach his, you can say home, because he's start to move from office. Okay, to reach his home. So can we say that the point is, we know that s1 is the initial speed. Let's say the final speed is 4 by 5 of his usual speed. Can we say that this is 4 by 5 of usual speed, and this is equal to, this is t2. In the second case, he is taking 5 minutes late. It means if initially he was taking t minutes, in the second case he will take t plus 5. Okay, this 5 is 5 minutes, right? So can we say that s1 cancel, the 5t is equals to 4t plus 20. It means the t is equal to 20 minutes. So we can conclude from here, initially the person was taken 20 minutes from his office to home. Okay, let's say now come on concept number 3, and the concept number 3 is very beautiful, and that is, let's say there are two persons, both start to move at the same time. Let's say by equation, the concept number 3, question number 3 is, let's say this is point A, this is point B, right? Both from this point A, a person, let's say Ram, and let's say at this point the person say Sham. Okay, both start to move toward each other at the same time, right? And let's say this person is moving with speed s1 and this person is moving with speed s2, and somewhere between these 2 points they meet here. Okay, let's say this point C. And the particular in this concept, what we are assuming here, we are saying that the given part is, in this type of questions, the given part will be always, if A is moving toward this direction and B is moving toward this direction, and they both meet at point C, after meeting at this point, B will move in this direction obviously, and the A will move in this direction obviously, right? After this is for A and this is for B. Okay, and the given concept is, let's say in your question the data given is, after this point A is taking T1 here minutes here, and after this point B is taking T2 minutes here, right? Let's say it's minute, it hours, it depend on your questions. Okay, the concept is the given data is, after their meeting point the time will be given. In that case what you will do, first we will discuss concept, after that we will take example. Okay, let's say you want to find distance between A and B. Okay, you know very well the given data is here, S1 speed is given, S2 speed for B is given. Okay, so can you say that if T1 time is taken by A from here to here and he is traveling with S1, so distance, if we will count distance from A to B, can we say that this distance AB is S1 into T1, S1 into T1, and the distance covered from B to A by B to A by B in T2 time, can we say that this distance is a speed into time, and this is S2 into T2. So total distance will be S1 T1 plus S2 T2. So this will be your total distance. Okay, let's say in the first question, in the first concept we want to find the distance between A to B, but in the second question we want to find the actual time taken by the time taken by both when they met to each other, right? Now we want to find after how much time both will meet. Okay, how we can find, we can say the time taken by this person from here to here is similar to the time taken by this person from here to here. So can we say that if this distance from B to A, and this distance is S2 T2, and this distance from A to B is S1 T1, so can we say that the time taken from here to here, okay, the time taken from here to here, S2 T2 divided by the speed of this person, right? So can we say that the time taken by Ram from A to C is S2 T2, that is distance, divided by speed of Ram. Okay, can we equate this equation with this? What the time taken by Sham is distance, that is S1 T1, divided by the speed of the Sham, and that is S2. So can we conclude that S2 square divided by S1 square is equals to T1 by T2. It means we can say that the T1, the time taken after meeting point, and the T2, time taken by after meeting point by Sham, the ratio of these two values is always equal to speed ka square ratio. Okay, the speed of the second person, it's also reciprocal somehow. Okay, it's also reciprocal somehow. Okay, now take question point part number 3. Okay, we are writing down, so let's rub it. Okay, so we can say that in the first part S1 T1 plus S2 T2 is the total distance, and in the second part T1 by T2 is equal to S2 square by S1 square. Okay, in the third part, actual time taken. Okay, the time taken by both to meet to each other. Okay, the meeting time. Okay, we are finding here meeting time, and the meeting time will be, time is distance by speed. Okay, the distance by speed, can we say that S2 T2, point number 3, the meeting time. How we can find meeting time? We all know that T is equals to, for this person, speed, time is equal to distance, that is S2 T2, divided by speed of this person, that is S1. In the second case, the time is equal to the time taken by this person, distance is S1 T1, and the speed is S2, right? So can we conclude that from 1 and 2, if we multiply these two equations, can we say that T square is equals to S2 T2 divided by S1 multiply by S1 T1 divided by S2. So what we will do, S2 S2 cancel, S1 S1 cancel. It means T square is equals to T1 T2. Okay, this is the third part. So our third result from this equation is T square is equals to T2 T1 and T square is equal to T1 T2. Okay, this T is meeting time, right? This T is meeting time. Okay, so this is very beautiful concept. For example, in exam time, during exam time, you will find a question. Okay, what type of question? The question will be like this. Let's say question is, for example, this is Agra. Okay, this is Delhi, right? A person from Agra, second person from Delhi start to move at the same time, and let's say they both start at the same time and they meet somewhere at this point C. Okay, this person who start from Delhi, his name is Ram, and the person who start from Agra, his name was Sham. Okay, after this point, after meeting point, Sham will take 6 hours to reach at Delhi and Ram will take 9 hours to reach at Agra. Okay, so the question is, just find after how much time both will meet. Okay, so what you will say, there is no requirement, just assume that this is D1, this is D2, there is no requirement of that. The basic concept is just use this concept where your T1 is T2 is given and you just put value here and just find out the value of T. So what you can say? You can say T square is equals to T1, that is 6 hours, and that is 9 hours. You directly will say T, value of T is under root 6 into 9, that is 54. Yeah, here 54 is not a perfect square. You can say that just replace this value 6 by 4. Okay, you will say just replace this 6 by 4. You will say this 9 into 4, that is 36, and the root of the 36 is 6. So you will say both will meet after 6 hours. So by using this concept, there is no requirement to solve each and every question by long method. Just apply this result directly in each and every question of this type. You can easily find out the answer. So let's move on the next part, that is concept number 4. And the concept number 4 is very beautiful, where you will generally find a question, speed is increasing, time is decreasing. Obvious, if speed will increase, time will decrease. And the second part, where speed will decrease, time will increase. The point is, let's say if a person moving from his home towards office, okay, right? The concept is, let's say if a person moving with speed s and will take time t. But the point is, if a person's speed is increased s1, obvious the time taken by him t1, he will take t1 time less. Okay. The second point is, if this person decrease his speed s2, definitely time will increase. Let's say t2 time will increase. Okay, basically in these type of concept, you will generally use a concept, and that the concept is, you will say directly the actual time, that is t here, you can say this is equals to s, that is original speed, s1 increment in speed, divided by s1 increment in speed, and multiply by extra time taken by him. Okay, this t1 is the time decreases, so this is the decrement time. Okay, and this should be equal to, if a speed will decrease, you will say s minus s2 divided by s2 and multiply by t2. And what is this t2? T2 is the extra time taken by him, and here this t1 is the less time taken by him. Okay, so how can you say that? Let's say example. The point is, let's say if a person in this case moving with the speed s, right? If his time will decrease by t1, but obvious, the concept is point number 1. If time decreases t1, so less distance traveled by him will be s into t2. Okay, it means this distance should be covered by the extra speed, that is s1 here. So can you conclude this should be equal to S1, this is extra speed, and the time, the extra time, that will be t minus t1. So what is this concept? This concept is, it means if a person decreases, if a person will take t1 less time, in that particular time he or she will cover st1 less distance, okay, less distance, okay. It means the person should increase his speed s1 for traveling this distance in the particular range of time. So we can say that this st1 should be equal to s1 into that particular time in which he or she is covering his distance. Okay, so can we say that this st1 is equals to s1t minus s1t1, and here value of t is st1 plus s1t1, right? And this is equal to s1t, and this t is equals to s plus s1 divided by s1 multiply t1. So we can say that this result is nothing but comes from here. Okay, so whenever speed will decrease, you will take positive sign here. Or similar, in the similar way, you can say that when speed will decrease, here minus sign will occur, and you will say in this case time will be s minus s2 and divided by s2 multiply t2. Okay, there is one more condition here. Let's say this is the derivation, basically this is the derivation of these two concepts. Okay, let's take further concept. The concept is, the point is, let's say increment in time and decrement in time both are same here. Let's say this t1 is decrement in time because in this case speed is increasing. This t2 is the decrement, this t2 is the increment in the time because in this situation speed is decreasing. So can we say that if value of t1 and t2 will be equal, we will say s plus s1 is equals divided by s1 is equal to s minus s2 divided by s2, because t1 t2 are equal and they both will cancel with each other. Okay, it means ss1 ss2 plus s1 s2 is equal to ss1 minus s1 s2. Directly you will say s. It means s is common. You will you can take s1 s2 here, and this will come to s1 s2 divided by is equals to s s2 will come here as common, s1 minus s2. It means value of s is equals to 2 s1 s2 divided by s1 minus s2. So can we directly say that this is the original speed? This will be the original speed in this time. Okay, so actual time is equals to this and the actual speed is equals to this. Okay, let's take example on this. When the example is, let's say, so we are writing down this result directly here, and this is equals to speed is equal to 2 s1 s2 divided by s1 minus s2. Okay, let's take example on this concept, and the particular example is, let's rub this. The question is, let's say a person increases his speed 3 km per hour and reach his office 40 minutes. If a speed is increasing here, obviously 4 minutes less time will take. If reach his office 40 minutes less time. Okay. In the second case, if a person decreases his speed 2 km per hour, obviously in this case he will take more time. He will take 40 minutes more. Okay, so let's find number A. Distance between his home and office. Okay, number 2, let's find actual time taken by him. Okay, and the third point, you can find out his speed. Okay, these 3 conditions you have to find out. Okay, this is a particular question. If we can rub this question and directly write down the result. If 3 speed will increase, time 40 minutes will decrease, right? If a speed 2 km per hour will decrease, time 40 minutes more will take. Okay, so can we say that according to this concept, whenever speed is increasing, that is S1, that is 3. Speed is decreasing, that is 2. And the difference of these two values is 1. Can we directly say that the final speed, the actual speed of the person is equals to 2 multiply 3 multiply 2 divided by 3 minus 2, and the result will be 3 to 6, 6 to 12. So actual speed will be 12 km per hour. Okay, this is the actual speed. Now you want to find out actual time. So how can we find out actual time? Actual time will be S. You know S, and what is S? S is here 12, because this is actual speed. T is 12 plus, let's say, S1 increment in speed, that is 3 air, divided by S1, again this is 3, multiply T1 increment in time, decrement in time, because this is the case of increase in speed. Okay, 40 minute less will take. This is 40 by 60. So can we say that this is 15 and this is 3. This is directly 5. This is 0, 0 cancel. This is 2. This is 3. Can we say that this is 10 by 3? This is 10 by 3, and this is your time. So we can say that this 10 by 3 is the actual hours. Okay, so we can conclude that actual speed is 12 km per hour and the actual time is 10 by 3 hours. So can we find out the distance? Yes, we can find out. And the distance will be speed into time. And the distance between his home and his office is nothing but speed, that is 12, multiply time, that is 10 by 3. And we will say that 3, 4, 12, the distance between his home and his office is 40 km. Okay, so basically this is the concept number 4. Okay, now proceed on the next part, and that is, let's say there is only time given. So how can you find out the distance, speed and all? Let's say, for example, concept number 5. Okay, let's say this is Delhi and this is Agra. Okay, let's say you start to move from Delhi at 7 a.m. and you reach at Agra at 10 a.m. right? And the same person start to move from Agra at 7 a.m. and reach at Delhi at 11 a.m. Okay, the point is you have to find out at what time both will meet to each other. Basically, in this fifth concept, you have to find out between Delhi and Agra, both person will meet at what time. So can you say that? Let's say there is no distance given here, there is no distance, there is no speed given here. So the question is, how will you find out time? Because the time is distance by speed. There is no distance, there is no speed. So how we can find out the basically time? So the point is, let's say we can assume anything. Let's say the distance is between 7 to 10, the time is 3 hours gap, right? And in the second case, this gap is 4 hours. Nothing, just assume that the LCM of 3 and 4 is 12. So we will assume that this distance is 12 kilometer. This distance basically is 12 kilometer. So what does it mean? We are assuming this distance. We are not saying this is the actual distance. You can take 24 also, 48 also, it doesn't matter. Just take 12 kilometer is the distance. Okay. So in this case, if this is the 12 kilometer, if we will discuss, first of all, we should discuss the concept of relative speed. And what is that relative speed? For example, relative speed is if a person start to move from point A and a person B start to move towards A. Okay, if a person from this point start to move toward B and person from this point start to move towards point A. Okay, this person is moving with speed S1 and this person is moving with speed S2. So after how much time both will meet to each other? Let's say this distance is D. The relative concept is, let's say, take it reference and stop this person. We are saying just this person is at rest position, and you will say that we are giving S1 speed, S2 speed to this person. So can we say that this person will meet to this person at this point, but not in reality, but we can find out the time, and the time is distance by speed, and the distance is D, and the time distance by speed, and the speed will be, this is not S1, this is S2, S1 plus S2. Okay, so same concept we can apply. This concept is relative speed, and this relative speed concept we can apply here. How we can apply here? Let's say we know we are saying the distance is 12 kilometer, right? Now just we have to find out the speed. So how can we find out the speed? We all know this is the step number 1. The speed for this person which is moving from Delhi to Agra. Speed is equals to distance, that is 12. Distance by time, and the time taken by the person who is moving from Delhi to Agra is nothing but 3 hours. Can we say that this is 4 kilometer per hour? Okay. Now I am rubbing this, okay, basically is nothing, we are using this concept here. This is the point number 1. And the second case, if a person is moving from Delhi to Agra, right, Delhi to Agra. The point number 2, we are finding speed of the second person who is moving from Agra to Delhi. Again the distance is again 12 and the time taken by him is 4. Can we say that he will move with speed 3 kilometer per hour? This person is moving from Agra to Delhi, right? Let's say we want to find out after what time both will meet. So can we say that again the concept of relative speed we can use here, and the time will be distance, that is 12, and S1 plus S2. He is moving with 4 km per hour and he is moving with 3 km per hour. So can we say that directly? Both will meet after time is distance, that is 12, and the speed will be 3 plus 4, 7. Okay, after 12 by 7 hours, both will meet to each other. Let's take one more example here. The point is, a boy goes to school with speed 5 km per hour and reach 6 minutes late. Okay, this is the boy home and this is his school. A person goes to school with speed 5, right? And he will reach at 6 minutes late. 6 minutes late. In the second case, if he travel with 6 km per hour, he will reach 6 minutes early. Okay. The point is, find the distance between home and school. So we know that previously we have studied the topic where distance was same. The distance was same. And we exactly remember that when the distance was same, the speed ratio is always equal to the reciprocal of their time ratio. Okay. So here, value of S1, that is, let's say this is 5, and the value of S1 by S2, that is equal to 5, S1 is 5 and S2 in this case is 6. Okay, can we say that S1 is 5, S2 is 6. It means T2 by T1, if this is 5 by 6, it means finally he was taking 5 minutes, initially he was taking 6 minutes because T1 is representing this data, T2 is representing this data. Okay, so can we say that if this point is representing actual time, when he was moving with speed 5, he reached 6 minutes late. 6 minutes late means 6 minutes late. We are assuming this. Okay. If he moved with speed 6 km per hour, he reached 6 minutes early. So can we say that there is a gap of 12 minutes between these two timing? So what it mean? It means there is a gap of, here speed ratio is 5 by 6 and the reciprocal of their time T2 by T1 is 5 by 6. So can we say that this gap is 1 and this is nothing but 12 minutes. So can we say that initially when the speed was S1, he was taking 6 multiplied 12, that is 72 minutes, right? And finally when the speed was 6, he was taking 5 into 12 and that is 60 minutes. Okay, so can we say that the speed is, if in the 60 minute, in this case, in 60 minute is the time, okay, and the speed is 5 km per hour. So can we say that the distance is a speed into time, and the speed is 5 and the time is 60 minutes, but is nothing, it's 1 hour. So can we say that the distance between home and his school is 5 km. So the distance is 5 km. Okay, what we did here, basically we are using here same distance concept, and which is nothing but the speed ratio is always to the reciprocal of the time ratio. Okay, let's say thank you so much.